the key thing was, we were looking at all these different things sticky boom could be used for. It could be used for orbital debris. It could be used for satellite servicing. It could be used for these missions like Mars Sample Return. But at the end of the day, we were trying to find a market where A, it can make a difference, but B, we wanted to get into a market that was more commercial. Something where we could be making, something where you could be selling a commercial product where, when you do something under a government contract, you're limited to like a 5%, 5 or 6% profit margin. Sometimes, in rare cases, you might negotiate it up to like 10%, but your profit margin is fairly limited. And for investors, that's not necessarily what investors are looking for, and that's also not necessarily the best thing for making a big difference in the market. And so we're trying to find a commercial market where we could get into kind of value-based pricing, where it's like our price is based on the value we provide, not the costs and inputs going into it. And that's what led us to this direct-to-station idea. Like direct-to-station, in a nutshell, is that we've come up with a way using a long sticky boom and another system that we're calling Safe Pilot to take an upper stage that isn't designed for prox ops, like anything from a Falcon 9 upper stage, Atlas V Centaur, down to nanosat launch upper stages, and enable it to deliver payloads safely to the space station by itself without needing a separate prox ops vehicle. Right now you want to deliver something to the space station, and those upper stages only have a few of the required capabilities you need to safely deliver something all the way to the space station with existing systems. But what we wanted to do was find a way to offload or eliminate those capabilities they lack and allow them to deliver to the space station in a way that, for the nanosat launch guys, it's critical because you're not going to, you got a 20-pound payload, you're not going to be able to pack a mini Dragon and any useful payload into that. And so in their case, they just can't service this market at all without a system like what we're trying to develop. And then, for bigger systems, our hope is that if we can prove this out on smaller systems, this would bring back one of the capabilities we lost with the space shuttle of delivering large payloads to the space station, like new modules, expansion, things like that. Because, an Atlas V or a Falcon 9 can lift as big, both volume and mass-wise, of a payload as shuttle could, but not with a prox ops vehicle along with it. And if you have a system that can offload the hard part of the last mile problem to the space station itself, all of a sudden you open back up that capability that's been lost of delivering large payloads to space facilities. I originally came up with the idea because of my interest in propellant depots. A friend of mine at Lockheed Martin, Josh Hopkins, wrote a paper about 2 years ago where one of the big concerns he brought up is he said, you look at the vehicles that it takes to deliver stuff to a space station, and they're really expensive. And only a tiny fraction of the amount of mass you put into orbit actually ends up as delivered payload to the station. And there's a very expensive heavy wrapper put around whatever you're trying to deliver. And the point he made was that, there's this magical $10,000 a kilo that that people have been using as a price point at which depots make sense. If you can sell propellant at $10,000 a kilo, it'd be very useful both for NASA missions and potentially for commercial missions. And the problem he pointed out is that, these COTS vehicles aren't there yet. Like they're at 20, 30, 40, or even more $1,000 per kilo. And his point was that using existing approaches, he didn't see a way that you could get it down below that. And I took that as a challenge, It's like, what can we do to change the equation? What can we do to make it so that you take this big, heavy, expensive wrapper and replace it with a lightweight, cheap throwaway wrapper that doesn't cost a lot of money? What I wanted to do is, how can you deliver propellant to a space station where the wrapper was a tank with insulation and some fittings, and that's it. And everything else is stuff you already had to have on the upper stage anyway to get it safely into orbit in the first place. So that's that's why I invented Sticky Boom in the first place. Is I wanted a way to be able to, offload those capabilities to a space station side system, that could allow anything from nanosat launch vehicles, early fully reusable vehicles like the ones that a lot of suborbital companies would like to do as a next step, all the way up to things like Falcon 9 and Atlas V, where anybody can deliver propellant so long as they've got the right fitting connection. And now all of a sudden you've opened up a market. Propellant's cheap. Anyone can launch, if you can make it to orbit, you can deliver propellant. And it divides up as small as you want and into as many chunks as you want. And so long as you've made it easy to do the deliveries, now somebody comes up with a new launch vehicle, they've got an initial customer. Jordan Kerr wants to do his laser launch system and makes it work, he can deliver propellants to a depot. X-Corps wants to do a follow-on, or Maston wants to do a follow-on to their suborbital vehicles that actually can deliver small payloads to orbit. They have a customer. They have a customer that has doesn't have really super high, requirements. We're not launching people, we're not launching precious national assets. We're launching commodities that on the ground are worth almost nothing. I mean, they're cheaper than milk. And, on orbit, they're worth a whole bunch. But anyway, so that's kind of my vision there is, create a market that's big enough that you can start opening up the launch market for everybody else. Not just the rocket reusable launch vehicles and, small ones, big ones, laser launch, gun launch, anybody. Can deliver to that market, and you've got an initial place where you can start get real competition, drive the cost of orbital transportation down to the point where you can do cool things in space, do cooler things in space than we're currently able to. Sorry, so that was kind of a long spiel, but so that's what we're trying to accomplish there, and pulling it back to the initial market. That's the big blue skies, big picture. The initial market we're going after is fairly pragmatic. There's people who are currently doing research on the space station that are trying to do commercial research. They're trying to do vaccine development. They're trying to do things like that. And they're having to compete with terrestrial counterparts. The station provides some pretty amazing, secret sauce. It allows you to do some things that are hard to do on Earth, but they're still competing with companies that can order something and get it, from McMastercard next day. Or Cole Palmer or whatever. I mean, if they need a part from the other side of the planet, they can get it there the next day if they want to. You're on the space station, you're lucky if you can get something turned around in 6 months. And what we're trying to do is we're trying to create a system that basically allows space-based researchers to move at a speed of business that's competitive with their terrestrial counterparts. Because if you have that way to do experiments in a rapidly iterating kind of fashion like your terrestrial counterparts can, and you have a unique asset like space, like on the space station or Dragon Lab, and all of a sudden you've got a strong competitive advantage, and you're going to see more people coming into it. So that's what we're trying to do. We're trying to meet that end user need, and we're trying to hook them up with the nanosat launch community to allow them to service this need that currently nobody can service, but they could with our help. So that's kind of the storyline. And most of our focus business-wise, I mean, we're still talking with people about these backup markets like orbital debris mitigation, satellite servicing. We're definitely interested in those, but our main focus is working with station operators, working with prox ops teams, working with end users and nanosat launch companies to find a way to make this whole system work.
And that truly will make a difference.
Yeah, we pulled the, it's like we've got this comic posted on the wall of our office. It was one that it was a Far Side that Ian Garcia found like during our run up to the LLC. It shows two spiders at the bottom of at the bottom of a slide with a web stretched across the slide in this playground, and one spider saying to the other, "If we pull this off, we're going to eat like kings." But I mean, this is a market that has huge potential, revenue-wise, but it really does have the potential to change the way that space transportation is done. And the cool thing is, it's a small enough chunk that a small company can realistically attack it with the right strategic partners. So we're trying to build relations with the strategic partners we need, both on the NASA and commercial side, we're trying to find some intermediate destinations where we can prove this out with a lower regulatory burden, like such as Dragon Lab. Where we can demo it on Dragon Lab and maybe even allow Dragon Lab, like this is a SpaceX Dragon with a bunch of experiments crammed into it. Imagine if on Dragon Lab you could send you're doing an experiment, maybe it only takes 4 weeks. You don't have to wait for everybody else to get their stuff done. You can send a sample down, and analyze it on the ground. You can learn something and say, oh, if I try it again with as you're doing a vaccine, if I try it again with these gene tweaks, I want to see, we found something interesting over here. Let's explore it further. You don't have to wait 6 months. You can launch it again and have it up there within a week. I mean, just the pace at which you can move your development forward, is huge because time to market matters. I mean, for a company, every day that you're waiting for results is a day you're paying people payroll that, and there's a delay between when you put the investment in and when you get the return. I mean, I'm a manufacturing guy, so I'm always looking at, you invest in something, you've got a work in process inventory, and you don't get paid until the customer buys it. So it's like, how can you make that as quick as possible so you're turning money around as fast as you can and being more competitive. And in the case of these vaccines, it's like saving lives too. I mean, that's kind of cool. I like making money. I like changing the way space is done. But the whole thought that we can help people who are doing vaccines, get to market faster, get products on the market that could be saving people, that's neat. That's one of those. Ooh, I like that. It's like I'm an entrepreneur. I'm about making money and changing the world. But I like the thought that it's making money and changing the world, saving lives, and making space more competitive. So I'm really excited. We found a cool niche. There's plenty of risk, plenty of hard work ahead of us. I mean, this is big, but it's also just a huge potential, and it's just really exciting.